Newton's interpolating polynomial is a type of interpolation in which you will give in a points and the output will be an approximation polynomial that will fit the curve. So Newton's interpolating polynomial requirements is that step size or the distance is constant, so the x distance or the step size is uniform. Degree is equal to number of points -1. So this is the example of Newton interpolating polynomial. So by the given, so which is 0, 1, 1, 4, 2, 9, 3, 16, which our points. And remember that this is our x-axis and this is our y-axis. Find the second degree polynomial that will fit the curve. So our x is 0, 1, 2, and 3. Our y is 1, 4, 9, and 16. So this is our x sub 0, this is our x sub 1, this is our x sub 2, and this is our x sub 3. And also this is our y sub 1, y sub 0, y sub 1, y sub 2, and y sub 3. So combine, so the Newton's interpolating polynomial have a pattern. So combining these two, this and this. So 4 minus 1 to get the denominator, which is 4 minus 1, 4 minus 1, then 9 minus 4, and 16 minus 9. So to get the denominator, so 1 minus 0, 1 minus 0, 2 minus 1, and 3 minus 2. So if you calculated it, 4 minus 1 over 1 minus 0 is equals to 3. Then 9 minus 4 over 9 minus 1 is equals to 5. And 16 minus 9 over 3 minus 2 is equals to 7. So combining these again, so the numerator, so 5 minus 3 and 7 minus 5. So to get the denominator, so this is the pattern. Remember that to get this, so low, left, down, so 2. Remember, down, left, down, so 2, minus up, left, up, so 0. Then to get this denominator, down, left, down, so 3, minus up, left, up, so 1. So by calculating it, 5 minus 3 over 2 minus 0 is equals to 1. 7 minus 5 over 3 minus 1 is equals to 1. Then combining this again, so 1 minus 1 over, so by getting this denominator, follow the step, so down, left, so 3, minus up, left, up, so 0. So by calculating it, so it will become 0. So remember, this is our b sub 0, and this will be our b sub 1, this will be our b sub 2, and this will be our b sub 3. So, by the formula, so the next step is by the using of this formula, which is f of x is equals to b sub 0 plus b sub 1 multiplied by x minus x sub 0 plus b sub 2 multiplied by x minus x sub 0 multiplied by x minus x sub 1 plus and so on. Then remember that our b sub 0 is equals to, from our previous calculation, so it is equals to 1. Our b sub 1 is equals to 3, and our b sub 2 is equals to 1, and our b sub 3 is equals to 0. So by substituting the following, so f of x is equals to b sub 0 1 plus b sub 2 1 plus, or rather, our b sub 2 is, our b sub 1 is 3, so 3, 1 plus 3 multiplied by x, so our x is, so x minus x sub 0, so our x sub 0 is 0 by this, so remember that x sub 0 is 0. Then plus b sub 2, which is 1, our x minus x sub 0 is 0 plus x minus our x sub 1, which is from the previous, so our x sub 1 is, our x sub 1 is 1, so it is 1. Plus and so on. So by getting it, so it will become 1 plus 3 plus x minus 0, x minus 0, other, you have also 1 here, then no, so 1 plus 3 plus our x minus 0, because we eliminate the 1 here because it's 1 only, so x minus 1, then our f of x will be x squared by x multiplied by x, then plus 3x minus 1x plus 1, so f of x is equals to x squared plus 2x plus 1. So this is our answer. So to check if it's the right answer, we will use, so by checking, substitute all the x sub 0 to get the y-axis. So our x sub 0 is 0, our x sub 1 is 1, our x sub 2 is equals to 2, our x sub 3 is equals to 3. By this, by the given So, to get the y-axis, just substitute all 0 to the given function. So 0 squared plus 2 multiplied by 0 plus 1 is equals to 1. 1 squared plus 2, 1 plus 1 is equals to 4. 3, 2, 2 squared plus 2 multiplied by 2 plus 1 is equals to 9. 3 squared plus 2, 3 plus 1 is equals to 16. So, this is our y sub 1, y sub 2, rather, y sub 0, y sub 1, y sub 2, y sub 3. So, we get the right answer, which is 0, 1, 1, 4, 2, 9, and 3, 16. So we check that is right. Our function is x squared plus 2x plus 1 because we get the points that are given in our example. So that's it.